All right, we're going to go through the voltage lab here, and I pulled up the voltage lab sheet. It's two-sided. You have it in your module packet already. And if I just flip over to the simulation software, which you're going to use to do this particular lab, you know, I've already have the circuit already set up. So you're going to create something like this, and then you're going to kind of analyze it, investigate it, and to understand some things about voltage. Okay, so step one here says create the following circuit. So we've already done that. Number two says measure and record the amount of current in a circuit. The current in the circuit is, so when we open it back up, you can see here there's our ammeter, and it's saying that the current in the circuit is 0.90 amps. And so that's what we write for number two there. Number three, measure and record the voltage across the battery and light bulb. Note the brightness of the bulb. So I can see that the bulb here is kind of bright, and when I take my wires from my voltmeter here, see if I can get that to work for me. I get a reading over here of 9 volts for the battery, and when I do the same thing here for the light bulb, place red on one side and black on the other, I also get a voltage of 9 volts. All right, so this is what you're writing here for number 3. Question 4, what do you notice about the voltage of the battery and light bulb? Well, they're the same. Explain why this pattern exists. Well, what you got to think about is the electrons coming out of the battery have energy, because the battery is a power source for the circuit, and then the electrons passing through the light bulb, as you can see right here, are providing the energy so the light bulb can light up. So 9 volts of energy coming from the battery is being used entirely by the light bulb. So what the battery is providing or outputting in terms of voltage is what the battery, the light bulb is actually using. Okay, so that's kind of what you want to write down for question 4. Question 5, increase the voltage of the battery to 25 volts. Okay, so we'll do that. So we're going to, again, we're doing the battery here. So I right-click the battery, change voltage, and I can just highlight right there, type in 25, boom, and wow, you can see that the bulb brightness dramatically increases. Okay, so remeasure the voltage across the battery and light bulb and the current in the circuit. Again, notice the bulb's brightness. All right, so we can notice now that the current in the circuit is no longer 0.9 amps, it's now 2.50 amps. The voltage across the light bulb, which you had there before, is now 25 volts, and the voltage across the battery is 25 volts as well. So we increase the voltage of the battery, and the light bulb's voltage also increases, because what the battery is outputting is what the light bulb is using, and the current has gone up because now the voltage is providing a greater push on the electrons in the circuit. So what is the bulb's brightness compared to what it was initially? Yeah, it's a lot brighter. Question 7, what happens to the current in the circuit if we increase the voltage of the battery? Well, we saw it go from 0.9 amps to 2.50 amps, as you can see right here. So a greater voltage will increase the current, because if you recall, the voltage is the push or the force that gets the electrons moving through the circuit. And so if there's a greater voltage, there's a greater push, and more current is going to be flowing through the circuit. Question 8 here, what happens to the bulb brightness if we increase the voltage of the battery? Why? So again, the bulb brightness dramatically increased. So you can see these nice, rays of light coming from the bulb have dramatically increased in size. Well, why does that happen? Why does the bulb brightness increase if we increase the voltage of the battery? Well, it goes back to the idea that the battery here is providing more energy. So that means the bulb has more access to energy. The more energy outputted by the battery, the more energy can be used by the bulb. And so the overall output of light from the bulb will increase as a result. Okay. Now we have to increase the voltage of the light bulb. I do this by right-clicking on the bulb and changing the resistance to 35. Now, what we're saying here is not the measured voltage of the light bulb, but what's the actual written value of the bulb. Like, you know, you go into the store and you pick up a bulb. What's the voltage on the bulb, similar to the wattage and whatnot. So we have to take this voltage of the light bulb, and we're going to increase. I'm going to increase by changing the resistance to 35. So I right-click my bulb. I'm going to change resistance. I'm going to highlight the 10 ohms there and change it to 35. Watch when I click enter on the computer, and all of a sudden now some things have changed. Okay, so it says remeasure the voltage of the battery and bulb, remeasure the current in the circuit. Okay, so the voltage across the battery is 25 volts still. If I shift my wiring around here for my voltmeter and look, the voltage across the bulb is still 25 volts. But the bulb brightness has decreased because it takes a lot more energy for the electrons to get through a greater resistance in the light bulb, and our current has gone down to 0.71 amps. So that's what you need to write there for number 10. Number 11, what happens to the bulb brightness if we increase its voltage? It goes down because, again, it takes more energy now to get the bulb to have the same amount of brightness as it did before. Before it was, let's say it was a 9-volt light bulb. Well, it takes 9 volts for this bulb to be brighter. If the bulb's voltage is now, you know, let's say it's 30 volts, then it's going to take 30 volts of energy coming from the battery in order for this bulb to be as bright as it possibly can be. Okay, so what, you know, the written voltage on a light bulb is telling you, hey, here's how much voltage you need to move from the battery to the light bulb in order for it to be its brightest. Okay, and so because we've increased the voltage here and we haven't changed the voltage of the battery, the bulb has gotten duller. So if we want to increase the brightness of the bulb again, of course we have to increase the voltage of the battery. What happens to the current if we increase the bulb voltage? Okay, again, it went down 0.71 amps because really a higher voltage light bulb typically is going to have a greater resistance, which means it's going to slow the flow of electrons through the circuit even more. It's going to take more energy for these electrons to pass through the resistance of the, you know, the filament here in the bulb as the electrons are going from one side to the other. Okay, so what happens to the current if we increase the bulb voltage? It goes down because the resistance of the filament in the bulb has essentially been increased, and that slows the electrons down more. Question 13, how does the meaning of voltage for the battery and bulb differ? And I've already really said that, but just to revisit that idea, that the battery voltage is what the output energy is going to be given to the circuit. The voltage of the light bulb is the input of energy that the bulb is receiving from the circuit. So voltage of the battery is output of energy. Voltage of the bulb is essentially how much energy the bulb is actually going to be using. Okay, so we'll see you in some future videos using the software again.